Good morning. Welcome to Making Stuff with Chris DeHut. For today's video, we're going to take a look at using micro SD cards with the Raspberry Pi PICO. What we're going to cover today will be what the SD card is and a little bit of history about it, what it is used for, applications you might use them for with the Raspberry Pi PICO, what you need in order to use them. We'll cover the wiring of it with a fritzing wiring diagram, and finally we got a fairly lengthy example program that does a variety of things with it that you can incorporate into your projects. Micro SD cards are part of a long lineage of flash memory that is configured in a way that makes it easy for us to use and to put in and take out physically from an electronic device. This technology was invented by Toshiba in 1980 and has evolved greatly over the years. But prior to that, let's take a little walk through history of some of the media used for storing data going back just a couple of decades. This is the 5 1/4 inch floppy disk. This was used quite a bit in the 80s. And then was slowly replaced by the 3 1/2 inch disk. Interestingly, these are floppy, these are rigid, but they still called it a floppy disk. Now these two remained pretty dominant for quite a while until flash memory came along. And then compact flash cards came out. And these were used, not so popular in computing and in PCs and so forth, but actually in industrial applications. Computerized machine tools use this type of memory a lot. They were used, of course, in laptops and other things too, but the popularity never really got strong. Then along came the SD cards that were great in many applications. Computers started offering more of these slots to accept these. And then, of course, the main area where you'll see this style and size is in photography. Digital cameras are pretty much standardized on that type of memory. Now, today's version is this little guy, micro SD. And there are many applications for these. You'll see these, of course, used in 3D printers, in computers, in cameras, in cell phones. A lot of single-board computers utilize these, such as the Raspberry Pi, etc. So they are really the dominant format right now at the year 2022. And I'm sure that'll get replaced very soon. Now, interestingly, the smaller every one of these got, the greater the capacity of them. This, back in the day, would have probably had about 360K of memory or storage space, 360K. Going all the way around to the current, this particular unit's only 16 gigabytes, and I do mean only because there are larger capacities. But just to give you an idea of how good things are today, there are 46,603 of these floppy disks of storage inside that little SD card. So as you can see, we've evolved greatly in computer and microcontroller storage media over the years. And today we're going to focus on that very popular micro SD card, and of course using that with the Raspberry Pi PICO. Now, the Raspberry Pi PICO has an internal file system where you can store data in it. It's somewhat limited. I believe, I'm going by memory, I think it's 128K is the file size limitation for storing internal. And getting data in and out from this would require a USB cable connected back to your IDE, in this case like we're using, Thani. I do have a video for this, and I'll provide a link for that below. The limitation to storing data inside the PICO is, as just mentioned, file size, but to get it in and out, you need a USB cable and a computer device to pull the data out. So you've kind of always got to have this next to the computer, or at least within a USB cable range. And that's where an SD card comes in very handy. With the SD card, we could have this connected to our Raspberry Pi, enclosed in a fancy little enclosure, and to get data in and out and to move it to different devices, we just simply take the SD card out of the card holder. So one of the things you're going to need is an SD card adapter to work with your Raspberry Pi PICO. I'll have links for that in the description below. And of course you'll need the SD card, and that should be pre-formatted with the FAT32 file system on it, and you would do that on your PC before using it. Now you might be asking, why would I need to store data on a micro SD card from a Raspberry Pi PICO? Well, it depends on what you're making. There's many projects where we're using sensors to collect data. We can collect data about temperature, humidity, brightness in the room from a light sensor, which could also be used to measure daylight hours. We might be measuring gases from a gas sensor. How often a door is opened and closed, perhaps even what time of day a door is opened or closed. Or we could sense with a passive infrared sensor when somebody comes into a room or exits a room or an area. In all of those cases, if you're recording data, you would record it on some form of media. And in this case, the micro SD card is ideally suited for this type of application, or any of those applications for that matter. Before we get into explaining the program and the operation of a micro SD card with Raspberry Pi PICO, let's take a look at how it's all wired up on a breadboard. Now I'll use a fritzing diagram to help make it clearer, but here's our Raspberry Pi PICO. We've got a ground wire coming back to a ground rail, and then we've got a 5-volt wire coming back to a positive rail. And this device runs at 5 volts, but don't worry, the communications via SPI will be fine with this being a 5-volt power supply for this device. With the power out of the way, now we'll turn our attention to the data interface, and that's SPI. And the first wire that we're going to discuss will be CS, and that comes over to, we're using GP number 9 for our chip select. The next wire is our clock signal, that's our white wire, and that's going to come over to GP number 10. Our blue wire connects to MOSI, that connects to pin GP11. And finally, MISO is coming all the way around over to pin GP number 8. And that will fulfill the SPI interface wiring requirements. Now, from here, we'll take a quick look on the actual breadboard. The SD card adapter that I picked up has these right angle pins, which is nice because it goes right into the breadboard this way. But it is kind of difficult to make sure you get it in far enough. So make sure you press down far enough to fully seat this into the breadboard. But it also makes it difficult to look at from the camera view. So this is the whole circuit laid out. You'll see our power wires over here, and then our data interface wires over here, connected up the same way as in the fritzing diagram. As mentioned earlier, we need the Raspberry Pi PICO. We'll need the SD card adapter, which needs to have the SPI interface, and some wires to connect it all together, as well as having the SD card of, I presume, any capacity, and that must be pre-formatted with the FAT32 format. And you would do that on a PC or Macintosh or something like that before using it here on the PICO. Now let's go ahead and we'll run this program. I'm going to clear out the data down here, and we're just going to show you what we're doing first, and then we'll explain how. So we'll just click the Run button, and it ran real quick. So we'll go to the whole top of the output here. We're going to get a line that gives us some system volume information, kind of tells us about the file that we're currently working with. We're going to get that data and read it back. We're going to write some additional data, and that'll be 10 lines of data. And that data will be in the format of this. This is the actual data, and that was written to the SD card. And then at this point, I read the data back in that we wrote to the SD card. And I'm doing that in such a way that you can actually work with individual lines of data. Now, there's some tricks along the way here, or perhaps not tricks as much as areas of interest that you should pay attention to. One of them being, don't think you can process massive amounts of data in memory on the Pico. It has a very limited capacity of memory. Earlier I alluded to a few of the requirements needed to accomplish the ability to read and write data from an SD card. And of course, one of them was this adapter. That's just part of it. We also need a driver. Basically, it's a class library that allows us to use that in our program to read and write data to the SD card. And luckily someone wrote that, and it is freely available. And I've got a note for that here in our program. I'll also have a link down below in the description, and that'll also be a link on our companion website as well. So you'll need to get that driver, and it's nothing more than the SD card.python.py file. And you'll copy that into your Pico. A good part of this program down here, the basis for it, I pulled off of the DigiKey website. They have a lot of great program examples there, and I really liked how they laid it all out. Very nice, very clear, concise. And so I just took theirs and I've added to it some more features or capabilities to demonstrate more of how you would actually use it as opposed to just simply the functionality of it. So you may want to check out this link as well. Again, that'll be in the description below. Of course, the 3D card adapter with an SPI interface. Again, links I'll provide. Wired up and get a FAT32 formatted SD card of any capacity and put that into the slot, and then we can run the program. And that'll be what we're going to discuss right now. Before we do that, I just want you to look at the MicroPython driver for SD cards using SPI bus, and this is the whole thing right here. And so luckily we don't have to go through all the horrible details of writing all this code. Well, that can be fun for some people. It's certainly not fun for everyone. So thank goodness somebody created that library, made it available for us. And you would just copy that file, just as you would this one, onto your Pico. So we'll just do this real quick. I'll do an open Raspberry Pi Pico, and then there you'll see our two files that we're talking about. We will go ahead and import a few libraries. Machine gives us access to the hardware pins on the Pico. We're going to import our library, which was the SD card library that we copied in. And then we'll import UOS, and that is kind of like our file operating system, so that we can mount the file system down below here. So now these next two areas are starting to get our SPI interface configured. CS, our chip select, we will set that in our example on GPIO number 9, and we'll set that to high. Then we're going to initialize the SPI interface, and we're going to be running at 1 megahertz, 1 million cycles per second. And we're working with SPI interface number 1. We'll configure the data configuration. and then finally the next three pins that are required for the SPI interface. We're going to initialize the SDI card by just simply utilizing this class and creating the object SD. Then we will mount that file system using these few lines of code here and getting us set up as /SD for our directory that we're working from. And now we're going to go through and load the contents of the directory listing into a list for processing. Now this would be something that you may or may not want to do. Oftentimes, working with microcontrollers and data logging, you don't have multiple files. It's usually one file, but you may want to see what other files are on there for whatever reason and maybe act upon that data. So this is how you would get a listing of the directory of files that are in the SD card. Now this is where things get a little more interesting for what we would do. Up to this point, this configuration data is pretty well all boilerplate. You're almost going to have to do this just as it is, or if you want to experiment, you can try different settings. This one, of course, is just a loaded directory of the SD card, so you may or may not ever need that code. But here is more of what you probably want to do. And I'll just go over the notes real quickly. We're going to write some data to the SD card in a manner similar to a data logger. The data will be in a text string, and you'll write that to the file. Don't use numerical data in variables. You might get mixed results or maybe very poor results and not what you expect. Stick to text strings. And an important note is when you do this, if no file exists, it will be created, and if a file does exist, the data will be overwritten. You won't be like on a Windows operating system, you won't be given that option. It'll either create it if it ain't there, or it'll overwrite it if it is there. No takesies, backsies on that one. So now I'm just writing a note to myself, what's happening as the program runs. We're going to write some data. We're going to open a file with this statement, and we'll put it in directory SD, the actual SD card. And we're going to call it test01.txt, and W denotes that we're going to write data to it. And this is all being created as a file. We've got a counter, and then we're going to write our first line of data there. And this would be like a header line in your data. And I'm just simply saying this is my data for the data logger. And then we'll give it a \r and a \n. And that'll give us a return and a line feed in our data file so that it isn't one gigantic long line of data. We'll run this loop 10 times. And each time through the loop, we will write, or we'll create a variable called data s, and that'll consist of a number, a numeric value converted to a string, plus the word line of data, period, and then a return and a new line character. This line here writes the data very simply, file.write. Data S is the data that we're writing. We'll increment our counter, and then we'll just print it so that we know what we're doing up here. Or that would be this section right here where we're just printing our counter. And that will run. Now this would be typically the area inside your program. Say, for example, if I just hit enter here, better get a space there. This might be inside your actual main loop of your program. Coming down here, later on in your program, we may want to open the file again, and this time what we're going to do is read all the contents of the file that was created. And here's my warning to you. Important. Even though we wrote all that data to the SD card, it does not mean all that data will fit in the SRAM. The Pico has a limited amount of RAM. Now, obviously, in this case, we've only written 10 very simple lines of data there, so it will fit. In fact, I think on my testing, I got up to around 4,500, maybe 5,000 lines of data, and then when I tried to read it in here, it would give me memory errors. So you play around with it if you want, just for fun, but just keep that in mind. The Pico has a very limited amount of RAM, and you can't load massive amounts of data into it and expect it to fit. But the opening is really quite simple. You'll notice there's no loop. We just simply say with open, the file name, as read, as a file, and then we give it a variable name, and we read the whole file into that variable. So it'll be one massive amount of data in that single variable. And then I'm printing out SD, data S, and this is just for on the screen down here. And that was this whole line of data, starting out with SD, that was the SD line of data, and then what's exactly in each line of the file that we wrote right here. Now that still might not be very useful because all that data is in this file, but it's hard to get each line of data or address each line of data. So what we can do is read that in, and we can put that into a list to store all the data, and then that way we can iterate through the different elements of that list. So we'll start this way with creating our list, and I'm calling it list of data. Highly creative, I know. We're going to give our creative variable that defines the end of line, and we know that every end of line was written with a \r\n. So that's my end of line. Now we're also going to create a variable that contains the length of this massive file, which could be thousands of lines of code, but not too many. So that variable would be the length of that variable. We're going to start a loop, and what we're going to do is we know that the line length, or this L length, is really big because it's all the data in that file. And we're going to nibble away at that as we extract data out of it and write that into the various elements of the variable or the list called list of data. So as long as this is larger than 0, we're going to keep attacking it and pulling data out of it. So we have an index that's a pointer to essentially the end of line, which is denoted by right here. So we're going to find that end of line in the variable data S. And then we're going to use this line and append that up to the index character and put that into our list, which is called list of data. Then we're going to take our index point, the pointer to the start of the end of line, and we're going to add 2 to that, because what we're really focused on is only the R and the N. The 2 backslashes are, for lack of a better way of describing it, we'll call them hidden. And we're going to create this line called comp, or complete line. So now data S, our original massive variable, will be equal to data S itself, but only the portion from the end of the line all the way to the end of this variable. So we're just taking and removing the line of data we just copied into our list. Then we're going to update our line length our variable to represent what the length of this is, and keep repeating this. And of course this L length would keep decrementing every time we extract a line of data out of this variable. Finally, we'll go through, print a couple of blank lines. Then we're going to print out each line of that data in the variable, or in the list variable, list of data. So we'll have an index pointer called item. While item is less than the length of list data, the number of elements in that list, we'll print each one, list of data, element, item. And then we'll increment item to the next one and the next one and so forth. and that will show up down here. And that's how you would get access to each line of data in your log data file. And that's really what is involved in reading and writing from a data file on an SD card with the PICO. There's a lot you can play around with in here. Some of it's going to be a little bit tricky in how you format, for example, this line right here. You might be having multiple numeric variables that you're going to put into that string. So you might have str parenthesis L parenthesis and then plus str, another word or another numeric value, the time, or it could be the temperature, the humidity, whatever data you're recording. You might have multiples of those across that line of data. And if that is the case, and if most probably what you want to do with this data is incorporate it into a spreadsheet for further processing, there are ways of doing that as well, very simplistically. Now, I would recommend, if you are thinking of doing that, to watch our other video for the internal file system on the PICO. There I explain the process of taking that file and bringing it into the computer and putting it into a spreadsheet program. And from there you can manipulate the data to your heart's content, creating charts and bar graphs and line graphs and all sorts of things. So this is pretty well going to wrap up how to work with a micro SD card on the Raspberry Pi PICO. I would like to mention that there are many videos in this series. Right now, there's about 60 of them I think I've got planned, and even more seem to be coming up as I start filming and getting this series put together. So with that, I hope that you take the time to click the subscribe button and maybe give us a like if you enjoyed this video. Also, I need to mention that this source file is in our companion website. You can download the wiring diagram as well as the source programs from the companion website, and I've got links for that down below. I'd like to thank you again for watching today. Really enjoyed spending time with you, and I look forward to seeing you in the next video.